Welcome and hello. This is a video exercise in MODSIM, and in this exercise we are going to be creating a custom reservoir operations using code. So to do that, we're going to go up to the MODSIM menu and then click on the custom runs to create our code. But before that, we need to sketch out our reservoir and add some data. So we're going to run our simulation first without any custom code, just to get a baseline, and then we're going to add the code and then run it and check out the change in results. All right, so here we go. I'm going to start by creating a network. I'm going to start the network with a non-storage node. This will be for my inflow. Let's go ahead and call that NS1. Pull the label off to the side and zoom in. All right, downstream of that will be another non-storage node. That'll be NS2. All right, let's move that over and connect them. Then I'm going to have one final non-storage node right here. We'll call that NS3. And then at the bottom of the network, I will have my sink. Connect those together and then connect those together. Also, I'm going to have a reservoir right here. I'll put it here and call it Res1, just like that. And then I'm going to have a consumptive demand node right here. That's going to be labeled D1. So D1 is going to get its flow from NS3, and then reservoir 1 will connect upstream to NS2 and then downstream to NS3, just like that. Okay, let's go ahead and add some properties. Or actually, let me go ahead and save the network. All right, I think this is the correct project directory. Yes, it is. Project. I'm going to call this exercise 24, then click on save. Okay, we're saved and good to go. First, I'm going to define the inflow at this NS1 non-storage node. So right click, properties. Okay, so the properties box popped up. And then what I'm going to do here is say that the inflow is 150 acre feet per month for the first 6 months. And then the next row down here, I'm going to set it to July 1st and say that the inflow is 200 acre feet per month. By the way, I should probably also mention that this exercise I'm doing right now is from the PDF file, the MODSIM 8.1 tutorials and examples. And then where I'm taking this from is within tutorial C, customization of MODSIM. There's a couple examples. This example number 2, custom reservoir operating rules. This is the example that I'm basing this video off of largely. There's a few minor differences, but for the most part, that's where I'm getting my ideas for this exercise. Okay, so just credit where credit's due. Anyway, here is the inflow for NS1. Click apply and click OK. Let's go ahead and define some reservoir properties. So right click on Res1 properties. And then in the general tab, which is already selected, I'm going to set the maximum volume to 1500. The minimum and initial volume will both be 0. The units are in acre feet. And then I'm going to set the priority down to 50. So the priority of the reservoir is actually going to be a higher priority than D1 demand. D1 demand, I'm going to use a priority number of 100. So the lower the priority number, the higher the ranking. All right, so the other thing I need to do here is click on targets. I'm still editing reservoir. And then I want to change the target volume to 1500. So we'll type in 1500. That's in units of acre feet, which means the target volume of the water in the reservoir is full because we set the maximum to 1500 right here. Okay, I'm going to click apply and click OK. Next, I'm going to define the demand at D1. So this is the consumptive demand here. In the general tab, I'm going to set the priority to 100, which it already is. And then the time series, this is going to be a constant 150 acre feet per month demand. So that's how that is. Apply and OK. All right, I'm going to go ahead and save the model and then run it. So there's save, MODSIM, run MODSIM. OK. All right, the model ran. This is a very simple 12-month simulation with a 1-month time step. Let's check out the Res1 results. So I'll right click on that icon, then click on graph. What we're seeing here is the flow. This is the flow into the reservoir. So here's the upstream flow. It starts at 150 acre feet per month. And then starting in July, it increases to 200 acre feet per month. And the reason why it drops down to 0 is because our reservoir has filled up by the end of September. Right, so that should be obvious if we check out the volume data. And here's that. In orange, that is our target. So it starts at 1500 for the rest of the year. And then in blue, this is the line that actually represents the volume in the reservoir. It starts 0 and then it increases to full at the end of September. And that's why it stays at full and why there's no more inflow for those last 3 months of the year. So that means we should have some demand satisfied in D1 for the last 3 months of the year. Let's go ahead and check that out, and then we'll get to our custom code. So right click on D1 graph. I need to change the left axis back to flow. And here's the shortage I'm looking at. Let's open up. The demand here is 150. The amount supplied is in blue, this surface inflow. It's 0 for the first 9 months, and then it switches to 150. It's actual demand for the next 3 months, the last 3 months of the year. All right, so what we're going to do here is add some custom code, and what it's going to do is actually satisfy the demand at this downstream demand node D1, not just the last 3 months of the year, but for the last 6 months of the year. And what the actual instructions are is when the inflow to the reservoir exceeds 150 acre-feet per month, the reservoir storage target should be reduced to 1/2 of the reservoir capacity. So let's take a look at what those numbers are. This is the reservoir properties. Currently, the target is set at 1,500 acre-feet. That's for the entire year. But once the inflow exceeds 180, which is halfway through the year, then this volume is going to readjust to be half of the maximum reservoir capacity. The reservoir capacity is 1,500, so 750 is going to be the adjusted volume as soon as the inflow, which we can find from NS1 properties, switches over to a value greater than 180. Right, so that takes place on July 1st. Okay, so enough talking. Let's get to the custom code. To do that, we'll go up to the MODSIM menu, click on Custom Runs. It's going to bring up our code editor here. And then what we need to do is modify parts of this script to do what we want it to do, save it, compile it, and then run it, and then take a look at our results. For the sake of time, I'm going to paste in the code and explain what I'm pasting in. Right now, I'm starting with a brand new, fresh template for the code, a boilerplate. So I haven't made any changes yet. The first thing I'm going to do is declare a couple global variables for my nodes, res1 and ns1, to keep track and set that target, as well as monitor what the inflow is. So I'm going to come down here to below the main subroutine, but before the other subroutines. Then let me just paste this in right here. So what I'm doing is what it says, declaring the global variables for my m_res1 and m_ns1. The example scripts use this lowercase m underscore sort of as a prefix to the node name or the variable name. So I'm just going to follow suit and adopt that same convention. Okay, next what we're going to do is on initialize the code that we want to run one time at the very beginning of all iterations. I'm going to paste in this right here. And what I'm doing is assigning those nodes. So my mres1 variable is assigned to the res1 node. And then the ns1 non-storage variable here is assigned to the ns1 node on the map. All right, the last block of code I need to paste in is code that does the actual lifting and does the actual work. That is going to be within the onIteration top function right here. So let's go ahead and make some room for that. And then boom, I'll explain what I just pasted in here. Actually, I got to resize this because it kind of goes far on that one line. All right, so what we're doing is at the beginning of the first iteration, that's what this if statement does. And then the end if statement's at the very bottom. So the only code that operates is if we're on iteration number 1, or I should say the iteration number 0, the first iteration. First, what we're doing is setting this current index. So we're keeping track of the current time step, but it's just going to be an integer index. And then down below that, we are checking the inflow and whether or not it's greater than 180. If the inflow is greater than 180, we're creating a new integer variable called mres1_size, which is the max capacity of the reservoir, which we know is 1,500. And to get that value, I'm just referencing this object, mres1.m.maxVolume. And then I'm setting the target content of that reservoir to half of the size. So if you wanted to trace back through the documentation, and we wanted to find, for instance, where is that max volume reference right here. What we could do is realize that mres1 was originally defined up here as a node. And then within that node, there's a field called M, which is a object which has its own property called max volume. So let's go ahead and just trace that down real quick to kind of get familiar with how this structure works. I'm going to go up to help and then contents. All right, so let's open up the namespace. And then here is the list of classes. Here is the node. Let me open up the node and then the fields within the node. We have this M field right here. The M node class contains all the information for a node that will be used in the model and can be edited in the GUI. So it's just the letter M, and it's of type M node. So we should have a class for M node. Boom, here it is. And then here are the fields. Now we should see one for max volume, which is right here. Max volume, it's an integer, and it represents the maximum volume for the reservoir node. Okay, so that's how you trace that down. I'm going to close that. Let's go ahead and save, compile, and then run. So I'm going to go File and then Save, or Save As. We haven't saved it yet. It is in my project directory already, so that's good. I'm just going to call this script1.vb. Oh, hold on. I need to change the language to VB again. So I'm going to cancel that. Yeah, that's right. So this is the syntax for C#. Sorry if you've already pasted everything in like I have, but up in the top, we want to change this to vb.net. I'm hoping that doesn't delete everything. It did. All right, so let's just make those edits once again. Okay, so just above sub on initialize, I'm gonna paste in where I'm declaring the variables. And then within on initialize, I'm going to paste in this code where I'm assigning the variables. And then within this subroutine on iteration top, I'm going to paste in this if block right here, which did everything I said it would to reset the target volume of the reservoir if the inflow exceeds 180. Okay, we're set to vb.net file, save as. That looks better, .vb. That's what looked wrong the first time. I'll call it script1 and then click save. Okay, so let's go ahead and compile now. If we have any error messages, that'll show up in the info box down here. I'm going to go File and Compile. Okay, I'm just going to say no to that. All right, so I got a message that it says it's been built with no errors. Let's go ahead and run the model now. So File and then Run. Okay, that was done. It was pretty quick. Let's check out our results, starting with the reservoir data. So I'll click on Graph, and what we're seeing here is reservoir flow. You can see we have zero flow out of the reservoir for the first 6 months, and then 150 acre feet for the 7th month, and then zero again. This is a little bit hard to interpret. So at the moment, let's go ahead and take a look at the volume. So the volume we see here, the target value is in orange. It's up to 1,500 for the first half of the year. And then that's when our inflow exceeds 180. And that's why the target has been reset down to 750. And that one release that we saw earlier in the month of July, which is this spike right here, I believe that's just the reservoir releasing this 900 acre feet down to 750 acre feet as sort of a correction due to the changing target. All right, so let's take a look at the demand in node D1 now. We should expect more satisfied demand. Here's the graph, and I've got to turn on flow. All right, here is the demand in orange at 150 acre feet. Here is the surface inflow. This is the amount of water provided to demand node D1. So instead of just 150 acre feet for the last 3 months, we now have that much flow delivered for the last 6 months. So that was all the instructions had, but they did go on to say that instead of using the inflow to this node NS1, you can also monitor the link flow, such as the flow between NS1 and NS2 to identify whether or not that reservoir target should be readjusted or not. So I'm going to quickly recreate a similar script to what we just had, except using the link as the element to observe with regard to resetting the target storage in reservoir 1. All right, so I'm going to go up to MODSIM, click on Custom Runs. Now, do I have the same run before? Yeah, so this is my same run as before. I'm going to go File and then new, and then make sure that I'm on bb.net. That's good. Not going to make that mistake again. And then let's paste in some similar looking code. I'm going to scroll down here. Here's our on initialize. Just above that, I'm going to create global variable right here. Again, it's going to be for the reservoir, but now it's going to be for reservoir size, and it's going to be for the link. So instead of these three terms all sharing the same row, like they did with the other script, they're all different types. Reservoir is a node, the size is an integer, and the link is a link object. Inside the on initialize function, I'm going to paste this in right here. What we're doing is setting the values or assigning mres1, mres1 size, and mns1 underscore ns2. We've seen this already, how we defined the reservoir as a node. But then as for the size, oh yeah, we've also seen this as well, where we're just using that m field within the node, and then max volume is one of those values. And then this is how we define the link. Instead of find node and then the name of the node, it's just find link and the name of the link. Again, we're referencing the my model object, which is what we defined right up here on line 7. All right, this on iteration top, I'm going to need to add the actual code to reset the target here. What we're doing is monitoring the flow through ns1 underscore ns2. There's no need to check the iteration number because this is not going to change between iterations. It may change between time steps, but not iterations. So if the link flow exceeds 180, then this flow right here is the same as it was before, so no difference there. This link flow we can also trace by looking through the documentation. So for instance, we know that m underscore ns1 underscore ns2 is originally defined as a link object right here. And then inside that, we have a field for ML info. And then inside that is a field for link. So let's go ahead and just track that down real quick. In the help contents, I'm going to expand the namespace and then the classes and then the link, which is right here. I'm going to view the fields for that link. Inside link, we're looking for ML info, which is right here, ML info field that calls the ML info class. So we should have an ML info class, which is right here. Let's check out those fields. And boom, here is our flow field. It is an integer value and it represents the current time step flow. Okay, so just wanted to be complete about that. Let's save this script as a script 2, and then we can compile it after that. So save as, this is our project directory. I'll call this script 2.vb and save. Go file, compile. See here. Okay, so script 2 has been built with no errors. That's good. If you do get errors, you will see the description and the line number down here. So that should be helpful to help you understand and fix what the error is. All right, so I'm ready to run. Let's go file and run. All right, so that's done. Now let's check out our results. They should be the same as they were before, but just a different way of achieving the same ending. Here's the graph for the outflow from the reservoir. I'm going to change the axis to volume. Now here is the target storage. Once again, here's the actual storage in blue. That looks good. Let's close that and then open up the graph for demand node B1 and then switch the left axis to flow. And then cool, that's the same as before. Here's our demand, and then here's the actual surface inflow with a satisfied 150 acre feet for the last 6 months of the year. All right, well, that was it for this exercise. What we did was create a network and then write some custom code to modify the operations, or rather the target volume of water in the reservoir based on the inflow.